evening, everyone. On behalf of Electrical, Electronic, Telecommunicational Sectional Committee of IESL, I warmly welcome you all to this public lecture on post-flood electrical safety, especially after the impact of the cyclone. And actually, this lecture is the first lecture of our lecture series, which will be addressed the national issues and also to make the public aware about the national incidents and issues. And now, without taking much time, I actually invite our chairman, Mr. Viraj Muthugala, to cordially invite our chief guest speaker and all the valued participants to this occasion. Thank you.
Thank you, Dishanta. I hope you can hear me.
Yes, clear. Yes.
Thank you. Good evening, everyone. On behalf of Electrical, Electronics and Telecommunication Engineering Sectional Committee of IESL, I warmly welcome you to today's webinar on post-flood electrical safety in order to protect lives, homes, and infrastructure. So recently, we faced one of the worst disaster situations causing many flood incidents across the country. So these flood situations leave behind serious hidden electrical hazards that can threaten the lives, property, if not properly assessed. So as engineers, we have a vital responsibility to guide the safe recovery through correct testing, inspection, and professional judgment. This makes today's session both timely and highly relevant. So we are pleased to have Engineer Kaushal Albetiara today, Chartered Electrical Engineer and Chief Executive Officer of Amity Power Consultants as our speaker today. With his extensive experience in electrical safety, testing, inspection, we are confident this session will provide valuable practical insights on safe post-flood power restorations. This webinar is organized in coordination with the IESL Technical Advisory Program, which is aimed at applying engineering expertise for the benefit of society, especially during disaster recovery. So I thank our speaker, organizing committee, and all the participants for joining us. And I also would like to encourage active participation throughout this session. With that, I invite Engineer Kaushal Alpitiarachi to begin his presentation. Thank you.
Thank you, Viraj. And first, I would like to thank the chairman, Viraj, and all the committee members. And saying good evening to all of you, I would like to share my presentation here with. Hope you all can see.
Yes, Mr. Kaushal. Yes.
Okay, we'll move forward. We have a very limited time. We'll try to discuss most of the things during the period. Yes, electrical safety during and after floods. The content as shared, this is the content, and we'll move forward. Yes, if you didn't get ready at the beginning, you will have to accept the losses. What does that mean? During the design phase, you have to consider all of these, and during the operation, you should have foreseen the risk. If we couldn't, then we will have to accept those losses. If you are already late, now the flood is happening, forget everything, electrical, everything, leave. Make sure to shut down your system at the origin. before floods. If the warnings are there, assess the possible flood levels with historical data and current data. Evacuate everyone except the team intended to be there during the mission. The team in the mission, you have to count all of them, issue a token, issue emergency kits if possible. Those kits shall contain gloves, tapes, flashlights, emergency flares, life jackets, and anything that you think it is important. But make sure any item plugging to electricity is not provided. Shut down or de-energize the complete electrical distribution system from the origin and all the load centers and feeders. That means all possible circuit breakers to open position. Next, if you could assess the flood and if you have time, remove electrical equipment, devices, appliances, including spare parts, and store them at a safer area. Only things which are practical to move. Don't waste time for dismantling of larger items, even though they are expensive. Generators, transformers, VSD drives, panel boards, switchboards, everything. If they are bulky and may take a lot of time, forget them. You are too late for that. Close all panel doors, entrance doors, and openings as much as possible. Again, I'm telling, don't waste time. Evacuate the staff in mission to a safer place before flood take place. Everyone have to be evacuated. If you notice the flooding has begun, forget everything and evacuate everyone from the mission to a safer place. Document all activities during the mission and take an inventory of items moved away from the site. You don't need to be there at the site to take this inventory. You can take it when you are at a safer place. During the flooding, it is strongly recommended and advised not to use any tool or equipment plugged into the electricity. Always use battery operated items. You may hardly need power tools, but you may need torches or any lighting devices. Make sure they are battery operated. Never switch on the electricity supply until the premises is fully restored and a professional, a certified professional or a competent person directs or allows the energizing. Make sure not to switch on the supply. During flooding, now you can't go there. It's a factory or a house or whatever it is. Get ready what you are going to do after the flood. You can study literature, collect information from different manufacturers, and study standards and prepare plans for recovery process and so on. Next thing, Now you know you are submerged. Some items have submerged, some have partially submerged, and try to find sources. Where to source those? What are the availability of items and possible lead times? Because this will be very crucial to set up your flooded facility back on live, because the availability and the lead times are much crucial. The demand may be very high because similar incidents might have happened for other places. Then, of course, focus on rehabilitation work. First, you have to think and assess who to be involved, when to be involved, what to refurbish, and how you are going to do it, what to replace, what temporary actions are possible till items to be replaced arrive at site, what to test, how to test, when and how to energize finally. So it's a big and a long process. So all these inputs are required for you to rehabilitate or restore your electrical system. Yes, understanding the risk of energizing flooded electrical system. Yes, this is the biggest thing. And what is the risk and why it is so dangerous? Electrocution, short circuit, electrical fire are the main risks. Electrocution. What can go wrong? The surrounding is wet. Your floor is wet. Your switches are wet. Your switch gears, relays, walls, all the surfaces are wet. So that increases the risk of ground faults. Probably the switchboards. Inside the switchboards, the switchboard might contaminated with water and other stuff. The danger, the main thing is the earth fault or a ground fault can happen, but your protection system is not in operable manner, or it is out of order to protect you. That's where the risk happens. So you can't stop the electrocution. That is why it is said to be very dangerous. Same scenario with the short circuit. Line to line maybe, line to line to line maybe, line to neutral maybe. Because of the wetness, the short circuit can happen. The fire. When a short circuit happens, it is prone to have fire. The added risk is with flooding, loads of chemicals, acids, and flammable liquid might have been mixed with this water content. So that increases the risk largely. Sometimes fuel may also be there. Different type of mineral oils. So that will spread the fire. And the complete electrical system, the operation will be unpredictable. You can't predict what this device will do. They are not reliable. They don't work as intended. The behavior of the electrical system will be unintended. That's why the access for switching on or energization is restricted. So what to do with following items if they were fully or partially submerged? Transformers, generators, ACBs, MCCBs, MCBs, contactors and other electronic devices, motors. The list continues. Busway systems, cables, and so on. Can they be really used? On what basis? What might have happened to them because of these contaminants? And what level of corrosion might have affected these devices, equipment, the oxidization? What have caused them? We'll see. First, after the floods, you have to assess your electrical system. What has really happened to what? First, again, I'm telling you, you are not allowed to energize any of the electrical infrastructure in the facility yet. After the flood, take an inventory of item as not affected, half submerged, submerged. Even some of your devices or equipment have not affected. The distribution system of that might have affected. So note them down. If you can add comments or can take photos, that will make it more sensible for your future works. Segregation. Segregate according to each type of equipment and devices. Transformers, generators, distribution panel and switchgear, distribution systems, motors, other electronic parts. This is not mandatory to do it the same way what I have proposed, but make sure it's not jammed. Make sure to be more clear and you can refer very easily for your restoration work. Assign your staff into teams and let them occupy these inventories. Some teams might get multiple items, but make different teams and give responsibilities of them for different teams. Plan semi-skilled labor for removing all solids, muds, liquid, and all these foreign waste stuff. Be careful. There can be dangerous and harmful material and substances, and you have to take care of your team. So issue all the required protective equipment, protective items, personal protective equipment for them, and keep first aid ready with you, and make sure in an emergency you have infrastructure for them to rescue and take to a hospital or to give medical assistance. Yes. Identify teams for rehabilitation works. This is big crucial. First, the in-house team. Your team. Who we are going to put for what? We have to assess their capabilities. Who are good at providing expert knowledge? Who are good at dismantling, servicing, and all the stuff, drying, installation, testing, supervising of activities, and so on. Assess tools required and tools you have. Equipment and temporary power, especially. You can't take temporary power and energize the system, but you may need power to pressure wash and so on. So for that, you can arrange temporary power with safer focusing safety. That has to be very safe. Employ experienced and competent outside parties to fulfill the missing requirement. Don't take the challenge, don't accept the challenge without aids. That is so dangerous. If you are not competent, seek for external advice, definitely, because that will save many lives. Identify potential suppliers for new items. And rehabilitation of items under service contracts, AMCs, will be better to proceed with the same team because they have the history of this item and they have their spare parts and they have the expert knowledge for them. This AMC might have been carried out by the manufacturer or a manufacturer recommended party or some other party who is competent enough. So better to proceed with them. Testing and a certification agency. Because all the things will have to be monitored. How they are being rehabilitated, how they are being recovered, how they are being tested, and after installation, how they are tested again as a complete system. And the party who is involved should be able and should be capable enough to give a go-ahead for a safe energization. From the inventory, further segregate what to be serviced and what to be replaced, or what are usable and what are for scrap. What are for scrap. This is the list. So now you will see, if you didn't plan well, what sort of losses you are going to face. This is of course an extract from NEMA guidelines. The NEMA has prepared a guideline for flood safety in 2016. And this is an extraction of that. And this is directly related with NFPA 70B. You can refer NFPA 70B chapter 32 for more details. These are the two standards we discuss these incidents and disaster recovery due to hurricanes, flooding, snowing, and all. Much more detail is there. So these are some extracts from these standards. Molded case circuit breakers, MCCBs, replace. If you check with most of the manufacturers, not most, everyone, they are also mentioned, those are to be replaced. Low voltage fuses, replace. Switches, replace. Busways, replace. Especially Mylar wrapped busways. The bigger bus bar trunking systems. If you have seen, those are wrapped with this mica based wrap. What you see, the same thing inside motors. This thing is wrapped around the each copper or the conductor, or copper or aluminum conductor, in multiple turns to achieve the insulation level and heat dissipation levels and the power frequency withstand levels. That makes very hard if water ingressed inside to remove. If you bake it too much, the insulation layer will be damaged. So if it is submerged or submerged for a long time and the water is ingressed very badly, trying to recover the bus bar is not going to work, and that effort is not countable. Powder coated busways, yes, you can recover. But here in Sri Lanka, we rarely use them. Actually, I didn't came across for the past period. And you have another type of bus bars where the air is used as insulation. That also can be recovered. Panel boards and switchboards. What are panel boards and what are switchboards? Panel boards, NEMA refers as wall-mounted and sunk type, smaller SMDBs, or switchboards, larger distribution boards. Those can be rehabilitated, reconditioned, depending on the damage. But items inside may not be no longer usable. Motor control equipment, adjustable speed drives, VSD drives and everything. Components containing semiconductors and transistors, electronic items, electronically controlled solid state contactors and starters, overload relays, those are said to be replaced. We'll discuss why later on. Manual and magnetic controllers, which can be taken apart and serviced. You can recondition. Motor control centers, except things that we said above to be replaced, can be rehabilitated or reconditioned. Power equipment, all electronic trip units, replace. High voltage circuit breakers, you can rehabilitate. Low voltage power circuit breakers, what are these? Are they MCCBs? No, they refer for ACBs. ACBs you can recondition. Electromechanical protective relays, meters and current transformers, yes, you can rehabilitate or recondition. Electronic protective relays, meters, current transformers, that means CBCTs and all, you have to replace. Low voltage switchgear. NEMA refers low voltage switchgear as transfer equipment. So they can be rehabilitated. Manual changeover switches and so on. Medium voltage switchgear, again transfer switches, can be rehabilitated, but any electronic part is embedded, you have to replace the particular part. Medium voltage fuses, replace. You can't reuse. All dry type transformers, regardless of kVA rating. This is referred to isolation transformers, auto transformers and all dry type control circuit transformers, replace. Liquid filled transformers, they said replace, but that depends on the damage happened. So you have to do pre-test and see whether your transformer is in a condition to rehabilitate or recondition or not. Cast resin transformers, said to be replaced, because if you see the cursor, you have these elements where your connection limbs for each windings are connected. The tap changing positions. The core itself is fully enclosed with a resin. But these are the area where you have the poor IP rating. If submerged at these locations, water can definitely ingress. And this particular winding is a sealed one, so you can't rehabilitate. And the core is open. The damage happened to the core makes it worse. So you have to replace those windings and you have to rehabilitate your core. That means the complete transformer is going to repair and maybe replaced. Your base and those rollers will be there for use. So there's no chance of taking the risk. Even that, after the rehabilitation, if that properly didn't happen, these might exist with so many of unbalances, noises, vibration, which would damage your structure and which will dissipate much heat, and the working condition of this transformer may not provide the intended performance. Others, all the electronic interrupters, protective devices, GUIs, metering, and all, you have to replace. Especially batteries. Cable trays you can use if not severely damaged. Fire pump controllers, lighting, ballast, LED drives, motors, smaller motors better to replace, but larger motors, yes, you can condition and reuse. Signaling, protection, communication systems, UPSs. All these items are for emergency services. So you can't rely on them if they are not in proper order. They may be in order, but how long? Will they work intended? Will they work as usual? How to take the risk? If you are suffering from a fire, if the fire controller doesn't give the command to your fire pump, what is the purpose of accepting that risk? If the UPS doesn't work, if this is a hospital and the UPS is provided for your operation theater, if that doesn't work, what is the purpose of having it? If the UPSs are catering your data center, if it is not working, what's the purpose of having it? So replace. Wires, cables, flexible cords. Wires or cables listed for dry locations, replace. For wet locations, you can use, but still, after checking what has happened, up to what level it has affected, you may be able to use under a inspection by a competent person. Fittings, outlets, junction box, all to be replaced. Conduits and tubing, yes, you can use, but if they contain more water and have a difficulty in drying, you may seek for another distribution path. Why we are saying, and those standards are saying, replace them? Because of the hazardousness of floodwater. The damage due to water for electrical equipment can happen by three types of water: white water, gray water, and black water. White water have very little or no contamination. Sources can be bathtubs, sinks, pipes, water heaters, fresh water, drinking water. That's white water. Gray water has contaminants, maybe water, wastewater getting out from dishwashers, washing machines, kitchens, and so on. Black water, very hazardous. Sewage, toilets, and flooding. Loads of chemical is there, load of contaminants are there, acid is there, other chemical and biological waste is there. So these water substances will increase or will damage your electrical equipment, especially those tiny electronic equipment, and they sit on those surfaces very firmly and create oxidation and sometimes short circuits, sometimes permanent layers. So that makes those electronic based and smaller unserviceable items malfunction, deteriorate, or out of order, and you can't predict. These are sticked very thoroughly. So without thorough cleaning, you can't remove them. So that cleaning might damage your PCB boards or your electronic items. So that is why they are said to be replaced. Power circuit breakers and HV circuit breakers, ACBs and high voltage circuit breakers. Yes, they can be reconditioned. And first, you have to remove them, dismantle them, and take to a place where it is dry. And usual cleaning practice, but you have to completely take apart, and cleaning and drying has to be happened in a very good manner. Chemical agents will have to be used, and thorough cleaning is necessary. A chemical like isopropyl alcohol, which is not diluted. Remember, it should not be diluted. Pure isopropyl alcohol, which has the purity of 99.8, is needed. This cleaning agent should not be harmful for surfaces as well as people who are in the job, and it should evaporate, and it should not leave any stain. You also can use acetone, but not thinner or any other harmful material which melts or which deteriorate plastic or ABS surfaces. You have to thoroughly clean them, and you have to dry them. Inspect whether they are very well cleaned. No oxidation marks are allowed, because that will propagate when it is enclosed and will have hot spots inside the circuit breaker and eventually will damage the circuit breaker, followed by an arc flash. So any moving parts, springs, all moving parts shall be cleaned and lubricated, and check for wear, corrosion and all. Any part that cannot be recovered shall be replaced. So make sure when you are rehabilitating this particular device, any part which is worn to be replaced, because you are doing a complete refurbishment for the particular device. Springs, latches, mechanical interlocks, or everything. And there are items to be replaced: trip coils, motor mechanisms, charging handles, UVTs, shunts, coils, trip units, any other electronic material will have to be replaced. Yes, electronic trip units, trip coils, spring charging motors, corroded auxiliary contact terminals, internal CTs. Yes, because those internal CTs are encapsulated with plastic. Because of that, if water ingressed into it, it is very hard to take them out. And if you flit it apart, you can't take it back to its previous condition. It's a sealed unit, but with vents. So you can't use them, you have to replace them. And tag all replaced components and keep a record. Thereafter, you can reassemble and proceed for your tests. First, you can start with insulation test with 500 volts. If things are okay, that means a desirable insulation level is there, yes, you can proceed further. Your drying will have to be conducted less than of 500 degrees Celsius for multiple hours. Sometimes you may need to have rests, and you may have to take shifts for the drying process, because the accumulated heat might damage your body and some other ABS parts. Following an inspection and testing shall be conducted after completion of servicing the circuit breaker. First, a visual inspection by a competent person. So you have to check for any residues, any oxidation present. Then you can proceed with the insulation test, mainly at closed position and open position. That means the switch gear at open position and closed position, among faces and top and bottom. At open position, top and bottom, closed position, between faces and neutral. Thereafter, with the body, because the chassis of the ACB is metal, and you have to check with the chassis also. Contact resistance test. For all the phases, you have to conduct. Especially the voltage withstand test, power frequency, voltage withstand test, because you never know at high surge currents, how this is going to operate, right? So you will have to give 2.5 kilovolts for 5 seconds, and we'll have to check. Thereafter, you can configure your protection settings, and then you will have to check the circuit breaker using the manufacturer's test unit as well, after replacing those UVT coils, solenoids, trip units, and all. That will give you a complete list of functions and the functionality of them. A hectic process. Panels and enclosures. Assess the enclosure for structural deformation. If any structural deformation is present, that's going to be very difficult, and that's going to be costly. If the structural deformation is minor, you may be able to replace some of the structural parts. If that is major, you will have to think of a new switchgear enclosure, a panel. You have to check for displacements of mounting frames, misalignment doors hinges, distortion of bus bar chambers, record everything, tag everything, clean all metal surfaces, interior chassis, mounting frames using non-moisture solvent, because this chemical and all will not be removed without a evaporating solvent, right? So you may need to have isopropyl alcohol there also. There are some other chemical agents which are not harsh as isopropyl alcohol, but they won't do the job. So better you use them, but that will cause sometimes your panel body, your paint structure with the glare. So that will damage the outer surface, but can't help. And you have to use lint-free clothes. Avoid wet clothes again. and water which can introduce moisture and corrosion. After cleaning, you have to do those touch-ups for the body. Pay special attention for corners, horizontal surfaces, and areas where water, mud, foreign debris can have collected. Inspect for rust, corrosion, or paint degradation, and note any areas require further restoration and further treatment as well. Examine all door beadings, seals, and all to ensure your IP rating. If you can increase your IP rating as well during this rehabilitation work. Check alignments, record everything you did. The power circuit of electrical panels, where you have your copper bus bar assemblies. Everything will need to be dismantled and thoroughly cleaned, because all these nuts and bolts, if you don't remove them, some water with those chemical agents, chemical and these hazardous things, acids and all, may sit between those bus bars, and in the longer run they will deteriorate your bus bar distribution system. Therefore, you need to flip apart everything and clean thoroughly. Well soaked cloth and clean with isopropyl to remove water, mud, corrosion, and all the contaminations. And all the area you may need to inspect for oxidation, and you may need to sometimes pile where the oxidation has happened. Thereafter, you can clean and apply any sort of heat shrink tubing if as necessary, and can reapply. Make sure the parts are leveled and well aligned, because the deformation of these bus bars will give you vibration, noises, and in long term damage insulators and for a short circuit or a arc flash or ground faults. Therefore, make sure they are very well aligned and no deformations inside the switchboard. Control cables and all, check for, remove all the trunking, check for the damage and mechanical and electrical damage. If possible, rewire, and minor damages could be restored, especially if the water ingressed through the sheath of these small stranded cables. Those will be oxidized and will eventually damage. All other control parts, indicators and all, will have to be replaced. Electrical panels, the component replace. MCBs you can't use. You will have to replace if fully or partially submerged. If you have seen the MCB, so many rivets are there. You hardly see any sort of screws apart at terminal points. So it is hard to dismantle and refix. Therefore, it is drying process and cleaning process is very difficult, and it's not pricey as well. You will have to replace. Same for RCCBs. Fuses, fuse holders, indicator lamps, digital power analyzers, energy meters, multifunction meters, arc flash relays, electronic relays, surge protective device, current transformers, protection relays, control relays, contactors, a big list. Most of them will have to be replaced. So it is easier to count things which can return. ACBs, bus bars. Most of the others will have to be replaced. Some MCCBs which have higher ratings, especially on category B, may be able to take apart and service. But same thing for breakers under 630 amperes, because they also have much more rivets inside the MCCB and pretty difficult to dismantle, thus making it difficult to dry. So better to replace. Electrical panels testing. So after the flood, the recovery process we discussed, the same panel servicing, but focusing more on cleaning, removing oxidization, removing foreign substances, and removing oxidization and drying. Sorry. After that, a comprehensive visual inspection will have to be undergone according to BS 76871 latest editions. Electrical and mechanical operations may be through a separate power supply, interlocks, bus bar connection, control cable connection, and tightness verification. Verification of earthing and bonding, configuration and connections, earth electrode resistance test, configuration of overcurrent and earth fault settings on protective devices and test. All the tests will have to be carried out for long time, short time, instantaneous, because you need to verify the solenoid operation and the trip unit operation. Insulation resistance test on bus bars, insulation resistance test on control wiring, contact resistance test to check you are developing hotspots at your connections and terminations, power frequency, voltage withstand test for panels, bus bars, circuit breakers as well. Transformers. Testing the transformer prior to the service. First, assess the transformer visually and see whether that is reconditionable, restorable. If so, assess what are the damages happens to bushings, control parts, relays, fin and body, valves, conservator, breathers, and all the other stuff. First, conduct an insulation resistance test and see what is the damage and what has happened. Then an oil BDV test. If it was in operation during the flood happened, a DGA test and a moisture content test. This is enough for you to take an idea what has happened to the transformer what's inside the transformer, what level of action is required. Cleaning those debris and all can be done, and depending on the test results, you have to select a competent party. If we are going to rehabilitate or recondition this, if you remember in the list that NEMA gave, they have specifically mentioned depending on the oil test results, you can decide whether you are going to retain this transformer or you are going to replace the transformer. If the transformer needs to be fully restored, that is strictly advised to be carried out by a suitable repairing team, as the drying, baking, and moisture removal process is very critical for the operation and the longevity of the transformer. I have seen many events that these transformers are being wound by third parties, and they are being blown at the instant they are energized. At the instant they are energizing. So make sure not to happen, because that makes you to order another transformer again. So don't let that happen. Find a suitable party. If you can contact the manufacturer, that's the best. Depending on the repair, test scope shall be selected. The major repair will need all factory tests to be conducted. You will have to check winding, if winding, rewinding has done, ratio, vector group, everything will have to be checked. And the core, magnetization, to check the core stability and all, and winding resistance, hypot test, all oil related tests, and yes, will have to be carried out. That depends on the repair. If there was nothing on oil tests, only a cosmetic repair to be have been done, no much testing is needed, except ensuring all the parts are intact, all are well torqued, and oil profile is acceptable. Generators. In this case, we are only talking about the alternator, which is related to electrical, and motors. Small motors, forget them, replace it. Others shall be completely disassembled, and a thorough, harmless chemical wash or water wash with high pressure is required, because you have to remove all these mud and stain inside your motor or the alternator. You have to thoroughly wash them. Then you will have to dry it well. After drying completely, check the insulation level. If you have an insulation and it is, you can assess with the results you are getting whether we are proceeding for a rewinding or enhancing the insulation. Let's say you're getting 500 kilo ohms, 1 mega ohm. Yes, you can refurbish. If it is short circuited, 0, then you will have to, most probably will have to rewind. If there's a hope, you can apply varnish and bake for not less than 24 hours, or follow the manufacturer's restoration guidelines, because that may precisely tell you what type of varnish you are going to use, and what is the temperature set point of your oven, and what is the duration of your drying or baking process. Replace all non-serviceable parts and electronics. Check for insulation, and if above 10 mega ohms, yes, you are safe to use. After assembling, a complete test for motors or generators will have to be carried out. If the generator, you will have to do a load test, insulation test, and all sort of tests that you are doing for your commissioning work. And again, I'm telling you, best to be carried out by the manufacturer or a competent party, recommended by the manufacturer, or you have experienced. After doing everything, can you energize? Yes. After all the rectification work is completed, all testing is completed and successfully finished. Following an assurance by an expert for the safe energizing, you can energize. You are ready. But be patient, because you have to pay first priority for safety. That's why we are employing all these protection systems and all to make the surrounding area safety for the people and the premises. So be patient. Wait until the testing and the experts give you the go-ahead sign. Right, now you suffered a lot. How many millions, how many billions have you spent? So don't you need to learn a lesson? Yes, of course you need. And don't you need to get ready? Yes, you need to get ready for the next flood. Document lessons learned for future references. Elevate all possible distribution systems, switchgear, panels, motors, generators, etc. if possible. Improve the IP rating or select devices, especially for those electronic equipment. You have equipment with improved IP ratings, that means gel-filled devices. If there are no any moving parts inside those electrical these things, there can be gel-filled material or parts available. Or make sure you are going to house IP maybe 68 IP rated distribution or enclosure, and improve the IP rating. Keep the staff trained, arrange tools, first aid kits ready, maintain an inventory of experts joined for the if happened again for the next event. Seek opinions for flood control methods and embankments or suitable methods to limit the criticality of the flood. Yes, investing on that much will be difficult as an individual or a firm if the government is not have taken actions, but you can limit. You can take opinions of hydrologists and civil engineers to limit the damage or the disaster happen. If the facility is completely flooded and same happens again and again, think of a relocation. At minimal, plan a disaster management system and a mini processing plant for a manufacturing organization, because if the flood damages your manufacturing facility, loads of your clients you might lose. At least to cater some part of some of them, or keep your name active until you completely restore. Plan for a disaster management and make sure you are not going to install it in a flood-prone area or other area where you have natural disaster or man-made disasters. These are some flood preventive measures they have taken. A few images I'm sharing. You can see there's a barrier, interlock barrier. They are available, and you can have elevation of the electrical system. There's again another barrier. There's a precast system, and you have options till 8 foot. So this will be, I think, will be helpful. And we'll discuss few case studies. An ME distribution with 3 kV and 3.3 kV voltage levels, half submerged, fully restored by the APCL staff. So this was designed somewhere, this was installed somewhere around mid-20s, maybe 5 to 10 years back. So expected the past flood levels and the expected flood level, the gap was not enough, and it was affected, and heavy servicing and cleaning was needed, and the downtime was high, and the expenses was very high, and the damage was very high. The competent party was needed. Some parts would have to be replaced because of the voltage ratings. The restoration was critical, and now it is operating fine. And another organization, just see how bad these ACBs and panels are being affected. You see water here inside arc chute chambers, and the ACB was fully submerged. And just check the stain retained on these surfaces. Every inch it has gone inside. So the complete disassembly is needed. All these electronic trip units, these relays, coils, and this motor mechanism, and this control wiring and other micro switches here will have to be replaced. We had to replace some springs also, and now this is in service. After the service, it was tested and is back on operation. Yes, this ACB can completely disassembled. These are the said CTs, right? Inbuilt CTs of your ACBs. These will have to be replaced. We checked drying, but it was not successful. We had to replace. This was the drying process. After a thorough clean, it was dried, and now it's in operation, followed by replacing all the electronic parts. This after the refurbishment. The APCL engineers and the other staff did the complete restoration and is back in operation. So there were about another 300 odd MCCBs. Of course, there were 10 to 12 ACBs which were rehabilitated, and there were about 300 odd MCCBs which were replaced. So ordering, sourcing is pretty difficult. With a minimum lead time, if you manage to bring them down to your premises, your process can be restarted quickly. This was a media station. They were in a hurry to print their newspaper, but just look at the distribution board. These breakers were wet when we visit there. If you see, still water is inside. No cleaning has been done. The stain is there, all the arc shoots. Just see the deposits. Here you can see wetness. And on these, here you can see on these arc shoots, you have wetness. Here on this arc shoot, you have wetness. Here you have residual water. So they wanted a certificate to provide to the utility to switch on the panel. So we cordially rejected, and we explained them the danger of doing it, and they promised that they are going to do a full recovery. After that, no hearing, and we are yet to be paid for our visits. If you switch this on, definitely you are going to face an arc flash and a disaster, because on top of this, the utility transformer was also placed. A case study for a submerged generator. Just see how much of stain, mud inside this alternator. Just see the color of this, the oxidation, how fast is that happened, and see the winding, the level of mud. Varnished, flipped apart, taken out, varnished, and baked. After the testing, this was completed successfully, and now in operation. So I would like to give about special thanks for all the attendees today, and Electrical Electronic Engineering Sectional Committee of IESL, staff of Amity Power Consultants Private Limited, Engineer Jayamal from Trade Promoters for providing those images, and Engineer Deepika Amarasinghe from Metropolitan Technologies, all my clients. All organizations develop these standards and guides related to the topic. Thank you. And if you have any questions, we have few more minutes.
Thank you, Mr. Kaushalya. It was a very insightful lecture. I think all the participants actually learned a lot, and I think these theories will be valuable and practical scenarios also in future. So now participants have the chance. It's open to you now. I think we have few minutes actually according to our schedule. So you can raise your questions. Then we can unmute you. So Mr. Kaushal will answer those. Thank you. Seems like the participants, I think, don't have any questions. So I think the lecture was really clear and very useful. So, right. So we got a question in our chat box. How we increase the IP rating of panel boards by Mr. Samit. Yes.
Yes, a good question. I would like to ask another question. What is the IP rating of panel boards usually used in the industry? There can be many answers, IP 41, 42, 44, 54. That depends on your moisture control and solid and liquid control level that you intended to have. Yes, to improve IP ratings, you can have beadings, sealants, sealing of glands, and barriers, and some other rubber-based items. If you check for them, those are available. And sometimes some modifications to your enclosure. Those can be used to improve your IP ratings. Some areas, as I mentioned, you can have resin treatments like for small enclosures. For bigger enclosures, what we discussed just now. Hope you got the answer.
Okay, there's another question, Mr. Kaushal. I believe it is visible to you.
Yes. What measures needs to be taken when recovering household circuits since not much professionals are involved in this process? Yes, that's the issue. First thing, never to switch on until at least a technician has undergone a visual inspection and do testing. All MCBs and RCBs needs to be replaced. And all cable termination ends at least needs to be cleaned, piled, and make sure not with oxidation. Enclosures you need to treat. All submerged socket outlets, switches will have to be replaced. All termination net ends in that socket outlets or switches will have to be cleaned. A proper insulation testing has to be carried out after a drying process. The drying will not be able to carry it out with mechanical dryers that need time and need to check water is trapped in conduits. So that's pretty harsh. Sometimes you may need to blow air and so on. If the water is still inside conduits, those may seep again into the distribution board eventually and will happen a short circuit. Therefore, the drying process needs to be taken care. And you may see if the distribution, the conduits in the slab area or in the higher area have a limited chance to trap water if that's the flood, that depends on the flood level. So drying, replacing, and the professional involvement is necessary. It is necessary even though that doesn't happen. So someone has to involve and taken care of it. Especially your RCCBs, MCCBs, drying, cleaning, and reconditioning of terminating ends is necessary and should be tested at least for your insulation resistance of the wiring system.
Okay, I believe Mr. Supunama Singh got the answer. Let's wait a minute if there are any other questions or not. Okay, there's another question from Mr. Kasun.
What would be a good level of insulation resistance regarding for a 33 kV step down transformer, say at 2500 volt or 5000 volt using a Mega. Mega is a brand, don't use that first. Insulation resistance tester you may use. Also, what is safer voltage level to test a particular power equipment like generators, say rated at 6.6 kV? Okay, a good question. I believe you are referring to the 33 kV side of the step down transformer. In different standards, they are proposing different DC voltage values. For up to 11 kV, IEC recommends 2.5 kV or 5 kV if it is exceeding 6.6 kV. Right? But American standards, they recommend 10 kV for 30 kV. And IEC says the minimum insulation resistance should be increased by 1 mega ohms per kilovolt from the low voltage minimum required insulation level. That is what IEC says. And NEMA, ASTM, NEC, they are telling 25 giga ohms and different for different products. For 6.6 kV, 2.5 will be the IEC recommended insulation injecting DC voltage value. I hope you got the answer.
Yeah, okay. Right, it's 5:08. So we can. Yes, I think Mr. Kasun got the answer. Right. So we can actually wind up the session, right? I mean, it's 5:08 now. So right. So no other questions, right? Okay. Now, actually, On behalf of the Electrical, Electronics and Telecommunication Engineering Sectional Committee of ISL, I actually extend our sincere appreciation to our resource person, Engineer Kaushalya Alpitiachi, for
Thank you.
the insightful and practical presentation. And also, I would like to thank President of ISL, Engineer Kosala Kamarudeniya, for his guidance, encouragement, and continued support uh, uh, throughout. And also, I would like to thank Chairman of our sectional committee, Mr. Engineer Viraj Mutugala, for his leadership and direction on making this timely webinar actually a success. Then I also like to wish and acknowledge the dedicated efforts of our organizing committee, including all sectional executive committee members for their commitment and the teamwork to deliver this program smoothly. And also my gratitude extended to the ISL CEO, Engineer Neil Abezekar, and the ISL Secretariat for their valuable administrative and technical support. And finally, I would like to thank all the participants for their active participation and keeping interest. And also, this session actually made very meaningful throughout. So thank you all for the participation and also raising questions. And we will meet from another session very soon. So hope to see you again. So thank you very much and good night to all.